Welcome to the DIY Honda Garage channel. The DTC P2182 specifically indicates that the Engine Coolant Temperature ECT Sensor 2 is out of range. This error can impact various systems in the vehicle, including engine performance, fuel efficiency, and transmission behavior. The ECT Sensor 2 is crucial as it monitors the coolant temperature and provides data to the Powertrain Control Module, PCM. The PCM uses this information to adjust fuel injection and ignition timing for optimal engine performance. The ECT Sensor 2 is typically located near the engine block or cylinder head and can sometimes be hard to reach depending on the layout of the engine compartment. Diagnosis and repair of this code are critical to prevent any long-term engine issues that may arise from inaccurate coolant temperature readings. The DTC P2182 error signifies that the ECT Sensor 2 has readings that are outside of expected thresholds. The engine coolant temperature sensor plays an important role in engine management by sending temperature information to the PCM. Based on this data, the PCM optimizes fuel delivery and ignition timing. The ECT Sensor 2 is usually found near the engine's coolant passages, making it crucial for accurate readings. If the sensor fails, it can lead to incorrect measurements that subsequently affect vehicle performance. Precise knowledge of the sensor's location is pertinent for effective troubleshooting and repair. There are several possible causes linked to DTC P2182. First, a faulty ECT Sensor 2 may generate readings that are under or over the expected range. Second, wiring issues, like breaks or shorts in the electrical connections, could impede the flow of accurate readings from the sensor to the PCM. Poor connections, caused either by corrosion or loose terminals, can also disrupt the signals that the system relies on. It is essential to check these components before concluding that the sensor itself is defective. Each of these causes can lead to enduring problems with engine performance if not addressed promptly. When DTC P2182 occurs, various symptoms may become evident. Commonly, drivers may experience engine performance issues, such as hesitation or stalling, as the PCM may not receive accurate coolant temperature readings. This disruption can lead to poor fuel economy, as the engine's air-fuel ratio may be wrong due to incorrect temperature data. Additionally, the engine light on the dashboard will likely illuminate, signaling the need for diagnostics. If these symptoms are present, it is highly advisable to conduct a thorough inspection to mitigate more severe complications. The first troubleshooting step for DTC P2182 requires you to turn the vehicle to the on mode. Utilize the Honda Diagnostic System, HDS, to check the parameters for ECT Sensor 2. You will need to observe the current values and compare them with the specified threshold of less than 0.14 volts. This provides an initial assessment of the sensor's function. If the current condition matches the threshold, it confirms the failure is duplicated, and you can proceed to the next troubleshooting step. If not, you should implement Step 2 for further investigation. In troubleshooting Step 2, repeat the process of turning the vehicle to the on mode and checking the values of ECT Sensor 2 with the HDS. This time, you should be looking to confirm if the ECT Sensor 2 reads more than 4.92 volts. Should this condition be true, it again confirms a duplicated failure, allowing you to move to troubleshooting Step 5. If this threshold is not met, it suggests an intermittent failure in the system. It is important to investigate for poor connections or loose terminals at both the ECT Sensor 2 and the PCM. Reproducing the failure under the original conditions is key to diagnosing the issue effectively. Step 3 outlines a focused approach on determining areas that may be contributing to the failure. Turn the vehicle to the off mode and disconnect the ECT Sensor 2 2P connector. With the ECT sensor disconnected, turn the vehicle to on once more. Check again using the HDS for any signal coming from the ECT sensor 2. You should observe if the values fall below 0.14 volts. Affirmative results lead you to the following step. If this is not the case, you may need to replace ECT sensor 2, as it indicates that the issue lies with the sensor itself. For step 4, turn the vehicle back to the off mode and jump the SCS line using the HDS. This process requires some wait time of over 1 minute for proper diagnostics. After this setup, disconnect the PCM connector A, 51P. Conduct a continuity check between test points 1 and 2 using the disconnected ECT sensor 2 connector. Test point 1 corresponds to the female terminal number 2 on the ECT sensor 2 connector, while test point 2 connects to body ground. If you find continuity, it reveals a short in the TW2 sensor wire. If not, the wire is likely okay, prompting you to check for any authorized service information related to your investigations. In step 5, revert to the off mode before you disconnect the ECT sensor 2 2P connector again. Afterward, connect terminals A and B together with a jumper wire from the ECT sensor 2 connector. Upon restarting the vehicle to the on mode, you need to measure the parameters via the HDS. You'll be checking whether the ECT sensor 2 outputs more than 4.92 volts. A positive result allows you to move on to the next troubleshooting step. If the condition is not met, it indicates the ECT sensor 2 requires replacement, as it has likely failed. For step 6, begin by turning the vehicle to the off mode and carefully remove the jumper wire from the ECT sensor 2P connector. Once the wire is out, turn the vehicle back to the on mode. It is crucial to measure the voltage between specific test points. Connect one test point to the ECT sensor 2 connector, female terminal number 2, and the other to body ground. If you find approximately 5.0 volts, you have validated the circuit conditions and can proceed to the next troubleshooting step. If the voltage is not present, you will want to investigate further issues with the wiring or connections for faults. Step 7 requires you to again make use of the SCS line by jumping it and allowing for more than 1 minute of wait time. After this wait period, disconnect the PCM connector A, 51P. Next, you will check for continuity between test points. Specifically, test point 1 comes from the PCM connector A, 51P, number 28, while test point 2 connects to the female terminal number 1 of the ECT sensor 2, 2P connector. If continuity exists, the SG6 line is functioning correctly, and you can continue troubleshooting. If there is no continuity, repairs to any open in the SG6 wire must be made, as this defect can lead to issues in sensor readings and overall system performance. In the final troubleshooting step, also jump the SCS line and allow more than 1 minute for the system to initialize. Remove the PCM connector A, 51P, and proceed with a continuity check between prescribed test points. Test point 1 is taken from the female terminal number 2 of the ECT sensor 2 connector, while test point 2 is connected to PCM connector A, 51P, number 43. If continuity is observed, then the TW2 sensor wire is functioning as it should, and you should consult any authorized service information for guidance. Should continuity fail, it indicates an open circuit in the TW2 sensor wire, necessitating immediate repairs to prevent erratic sensor behavior and improper readings that could lead to further complications. Final repair verification is crucial to ensure that the issue has been properly resolved. Begin by clearing any DTC codes stored in the PCM, which resets the diagnostic system. Following this action, conduct a test drive to allow the PCM to reassess the vehicle's current performance and the ECT sensor values in real-world conditions. After the test drive, Utilize the HDS to recheck the parameters of the ECT sensor too. Confirm that the readings are now within the acceptable range. If there are still issues, further diagnostics may be necessary to address any underlying problems. To prevent the recurrence of DTC P2182, regular preventive maintenance is necessary. Start by routinely inspecting all wiring associated with the ECT sensor for any signs of wear or corrosion. Maintaining proper connections, ensuring they are tight and free of contamination, can significantly reduce the possibility of faulty readings. Another vital aspect of preventive care is conducting scheduled coolant changes, which ensure that the ECT sensor remains submerged in effective coolant and functions optimally. Following these measures consistently can protect your vehicle against future diagnostic troubles and maintain its performance over time. In conclusion, understanding the implications of the DTC P2182 is essential for maintaining optimal vehicle performance. Conducting a thorough troubleshooting process helps pinpoint the root cause of the issue, leading to timely and effective repairs. Careful attention to wiring, connections, and maintaining the ECT sensor will contribute to minimizing future occurrences of this error code. Additionally, implementing preventive maintenance practices, such as regular inspections and cooling system care, will further ensure that the vehicle operates efficiently. By following these guidelines, vehicle owners can improve reliability and enhance the lifespan of their Honda CR-Vs. Please like and subscribe to the channel. See you next time.